Got it.
I think we've got it. I think we are on stage, gentlemen. Welcome aboard. Here we go again. Ladies and gentlemen, it is the 55th episode, number 55 of the SBAU Astro Hour. SBAU standing for Santa Barbara Astronomical Unit, our longtime South Coast Astronomy and Telescope Club. It's a weekly vlog podcast from our man caves and computer rooms where we cover just about everything the club is doing as the hopefully pandemic winds down. But our recent rocket launches and new probes in space, we got it all covered. Stargazing, new discoveries. Here are your headlines real quick this week. This is Pi Day. We'll talk about that in a minute. It's the 14th of March, 3/14. It's Pi, I got to tell you. Full moon on Friday. NASA's mission to an asteroid called Psyche. Saturn's 20 new moons. A variable star called Delta Cephei, and where Uranus is this week. Question about dark matter, how it's shaped in our Milky Way. So there's our incredible AstroNews monthly, what do we call that, Mr. Whittemore? It's
Masterpiece.
Newsletter, Astropiece.
Masterpiece.
Let's meet the gang. I'm Baron Ron Herron, your host, vice president of the club for several years now, though we haven't seen each other much, but we did on Saturday. We had an outdoor meeting at the Museum of Natural History's incredible Palmer Observatory, sitting right outside having our board meeting, and then a well-attended star party, the first we've had in years. I'll let one of our members, our outreach guy, talk about it. Let's meet the president, Jerry Wilson, 4 years running, my friend.
Good morning.
How's Pat Porgy and the dog and the tree out front?
Everything's good.
All right.
Everyone's good.
There you go. Chuck McPartland, outreach coordinator. He and his wife, Pat, who is the merchandise manager, also had her telescope up, I understand, Saturday night. I got frozen out for some reason. Former Westmont College science instructor, editor of the newsletter, Tom Whittemore.
Morning.
Also an incredible bread maker, I might ask. And Tom Totten, webmaster, technical wizard, very hardworking guy. Wouldn't be able to do any of this without Tom. He's married to Suzanne, his artiste lady. Tom's married to Maureen. And I guess we're waiting for BKM. That would be Bruce Murdoch, who is married to Bonnie, but he hasn't signed in yet. So, gentlemen, what's your ascertainment of Saturday night at the museum? Was it a rousing success without me?
It was pretty busy.
I'll bet. Well, who showed up? How'd they get the word?
Well, the museum had it on their webpage. The Independent had it on their webpage. Ed Hat had it on its webpage, and we had it on our webpage. So,
okay. And two of our members happen to be astronomy professors up at SBCC. I'm sure they told their students, right?
Well, Sean is, and Sean was there. He was out in the pit, and also I think. Ruben got it out on our Facebook page. That probably got a fair number of people too.
Ruben Gutierrez.
Yes.
He's the one that emailed us about a $300 award we're going to be giving at a science fair, I guess.
Yeah.
That's sort of news of the club. And we're going to meet, I guess, tomorrow night online for the workshop, right, Tom? Although we're not sure about the future of the workshop.
We'll hold it. Yeah.
All right. Today is Pi Day. Mr. President, what the heck? 3.14.
159265535.
I can't remember how you get going on that. It's a fraction, isn't it? And you multiply or divide the.
Yeah, right. It's the ratio of the circumference to the diameter of any circle. And it's a non-repeating decimal.
So it's not rational, Ron, so you can't do it as a simple fraction.
That's right.
And I want to point out that Chuck's latest password is the last 8 digits of pi.
Yeah.
The last 8. How do you get going on that long thing? Then what in the world triggers it? 3.14, and then how do you start getting the other numbers?
There's a way in calculus that I used to teach kids how to get it. Okay. It appears as an limiting thing in an integral. Okay. And it does not repeat, believe me. It goes on and on.
But how you remember it is just a moment of boredom at home and you've got time and you're looking for something to do, so you just memorize part of it.
Right. Yeah, I usually get the first 10, 3.14, 159, 265, 35.
Wow.
I think
Well, I
they're
thought it was-
up to what, 6 billion digits or 8 billion digits?
Yeah. And Warren Rogers, one time I was, bragging about my knowledge of it going out to 10, and he just knocked off 25. He did 25 of the followers. Pretty good.
I saw an article today that said, for most things you could go ahead and just use 3. You'd be off, but you'd be close
Right.
enough. But
Yeah.
then for things like the diameter of the solar system, now you got to use like 15 digits if you want to be accurate enough.
That's right. Yeah.
For some reason, I thought it started out with a 3 and a fraction, and you divided the bottom.
No.
What's the bottom part of a fraction called? The
No,
No,
Gotta
that
be
would be a
careful.
rational number, Ron.
right, Ron. You got to be careful. Rational number, like Chuck says, means a ratio of 2 whole numbers. It doesn't do that.
A fraction is a ratio. Top,
Well, it's a ratio of a circumference to a diameter for any circle, any size circle.
okay.
Okay.
I'm just
That's
saying.
not the ratio of 2 whole numbers. That's just the
There
ratio.
are fractional approximations to it, like what?
Yes, yes. Mhm.
Yeah,
11
as a matter of
divided by
fact,
7.
in Europe, they write their dates differently. And
Yeah.
so their best approach to a Pi Day is July 22nd. Because if you take 22 and divide it by 7, you
Right.
get an approximation of pi.
That's pretty good. Yeah.
Divided by 7, that must have been where we started. Well, speaking of comics and cartoons, let me make one quick announcement, gentlemen. First of all, our incredible speaker, he's probably watching on the night of Friday the 1st. However we do it, I guess we're going to probably be online again, Friday night, the 1st of April, a couple of weeks away. A young man named Merrick Brandt, who is a young grad student again, heading for a doctorate and a career in astronomy, going to represent Las Cumbres Observatories, going to speak on a bunch of topics, including his own specialty, which we just had another great talk about early this month on the first Friday of March from Riley Lynn Lewis, exoplanets. That's his expertise as well. But he's going to give us an update on LCO, Las Cumbres Observatory. And my thanks to Dr. Lisa Scory Lombardi and who's the lady that I should have gone through? Sandy, I guess it was.
Sandy Sia.
And that's based out there in Galita, as well as I guess in UK. They got telescopes all over the world. We're going to find out about it from Merrick Brandt. We had a speaker named Brandt once. I wonder if he's related.
I don't think so, but yeah, and maybe he's a cousin.
He now has word. He's watching on YouTube. Let's go to the sillies. Some of the silly science cartoons sent to us from our incredible president of 4 years. Whatever you call up, Tom, I'll see if I can match it here. Oh yeah, John Ben. Where is his? Timeline. Looking for a grave marker. Apparently, John Venn believed in eternity, but for his time on Earth, I guess he got caught in the middle there, as you can see.
Yeah.
No, that's the or of those two. So he believes in both A and B. That's him today now.
That's
Or, I
actually
mean, during his life.
that's actually the contraction of the 2 sets.
But an eternity can't really be circled, A or B, can it? Okay, keep it clean. You did bring that up for a second there.
Oh, let's go next one here.
Oh, here we go. Let me find it here.
It's on the screen, Ron.
Okay, Celsius, Anders Celsius. I got a Swedish astronomer who came up with the Celsius scale, died in 1744, age 43. And his rival, Mr. Fahrenheit, was convinced that he was 100. I still haven't learned how to do that. But reading Tim Crawford, one of our stalwart members, said he learned at a young age how to convert. The rest of you know how, and I haven't really done. Did you know? Go to another one, Tom. We got things to talk about. Here we go. Doctor, everyday things get more confusing and unstable. New particles, other dimensions, possible universes. I'm just getting used to it. But another crazy thing pops up. It's freaking me out, Doc. And the shrink says to his patient, I have an idea. Great physicist Grimaldi is giving a lecture tonight. Why don't you go along and I'm sure she'll explain things. Well, that won't help, Doc. Why not? I am Professor Grimaldi. Oh, okay. Got to book her as well. I don't know where you get these, but keep sending them. We've had this one before.
Oh, did
Yeah,
we?
I think that's an old Gary Larson. I
Oh,
recognize.
yeah.
Yeah, the women, he always was that way.
The one number he didn't come up with was 2. He's trying to make some sense out of Einstein's matter and energy equation. Let's see, E equals mc cubed to the 4th power to the 5th power. She says, now that desk looks better. Everything's squared away. Yep. Squared away. And he, oh, my God. Next. 2 astronauts sitting ready for launch. I'm nervous, Captain. Relax, son. NASA doesn't make mistakes. And here's the countdown. 9, 8, 6, 5. What? We're 7. They got in space anyway. All right. And here they are cleaning up the front. I guess it's another bug. I told you it wasn't a new planet. They don't, those big telescopes don't have glass out there at the end, though, do they?
No,
No.
but there's a
Most
real
of them don't.
situation. There's a real situation like that. But it was a radio telescope and they were scraping off the pigeon poo.
Yeah.
Also, the Parkes telescope down in Australia, they kept getting this weird signal and they were trying to figure out where it was coming from. And then they noticed that it was always around lunchtime and it was their microwave oven.
Pretty good.
Yeah, that's at 2.45 gigahertz.
Why can't we see B's second fire? That's what it says on my screen. Bruce?
Yeah, it did. It was there. It showed earlier.
Yeah, I see it.
I see that, but I don't see you, Bruce. Well, we'll introduce you.
Okay, start my video. I gotta. There we go.
There you are.
Okay.
His Honorable Ugliness has now joined us with his headphones. Any other sillies before we go to the serious stuff, Tom Tutton?
No, I don't think so. That's it for now.
All right, I had a bunch of stuff, but that's all right. We could. I like to go out to the moon. There is a full moon on Friday, right?
Yeah.
Thursday.
On Thursday it goes full,
Sure.
and it's
Yeah,
the worm. Why worm moon? Anybody know?
That's when the worms are getting active. It's springtime.
That's why I have trouble sleeping. Damn it. So early Friday morning. Let's
Yeah.
see. It's in Virgo. You want to do any on the moon, or you want to go right past? We got a
Well,
lot.
it'll
You
be
guys
nice and
fine?
bright for the Westmont observation on
Right.
Friday
I was
night.
just going to mention that. Thanks, Chuck.
Forgot
So
about
I've been, with the moon coming up around 8 o'clock in Virgo, it'll be in the east, right? It's going to be very bright out there. So it looks like Ken's going to be there with me on Friday.
Hey, okay.
Yeah. So it's been 2 years since I grabbed that guy up. So I'll probably visit it before Friday, make sure everything's okay. But what I was thinking of doing is basically targeting the 8-inch refractor on a lot of beautiful open clusters up in the northwest,
Yeah.
including Jerry's 1342. I always want to see that through an 8-inch refractor. I think it's going to be high enough. I checked the altitude. I think it's going to be high enough so I don't get horizoned out on the 8-inch. Okay. But that's the little scorpion, remember, Jerry, that you had a couple. Yeah.
As Tom is alluding to, around the full moon like this, we look away from the moon for our major objects and stuff, just as he's planning to do at Westmont. But that's also the theme of the talking points this week too.
Good.
So you see under the full moon, the worm moon, we look away from that to look at NGC 2403.
NGC 2403. It's in the constellation Southeast Port. I've never heard of this one. Maybe I missed it. Camelopardalis. Camelopardalis.
Camel,
Yeah,
yeah,
It's
camel.
the giraffe.
Giraffe? Is that what it is?
Giraffe.
It means
know, it has
spotted
like a-
camel, and that's what they call giraffes.
Yeah, it looks like
Oh.
cancer.
Okay. Is it up one of the 88? It's pictured up there, a giraffe. I don't recall ever seeing a giraffe, but anyway.
It's northern sky.
This is
So,
a,
Jerry, is
this
this an image of it, Jerry?
yes, it is.
No, wait a minute. This is a galaxy. Yeah.
Yeah, it's a galaxy.
That's
Yeah,
gonna be
constellations, yeah.
that's gonna be tough.
Just to show you real quick, Camelopardalis, I think it's this one here.
Yeah.
And then the galaxy 2403 is kind of midway between, I guess, Ursa Major and the Camel.
Okay. Yeah, giraffe. It's a giraffe.
I'd love to see its picture, how
For
it's,
people who own a pair of nice binoculars, there's a beautiful collection of stars there. That's a binocular object called Kemble's Cascade. It looks like a falls of stars. It's really pretty. That's a binocular thing. I would not try to get that at Westmont. It's too big.
So anyway, the galaxy has a bunch of really nice H2 regions in it, like M33 does. It kind of is similar to M33 in appearance. Here, the H2 regions are heavily emphasized in this picture.
Mhm.
That's really great detail on the filaments and things.
Yeah, it's a nice galaxy.
Yeah. Hard to see it that way in an 8-incher, Jerry.
That is.
so all your NG,
You probably get a hint of the very brightest H2 regions.
two big arms, right?
Yeah. Yeah. If it's hazy, don't forget, Jerry, the moon will blot out a lot of wonderful things, even in that direction,
Yeah, we're working under a handicap at the full moon.
Where is the magnitude 3-star Mosquito?
See that?
Is that in there? Is that around?
That's
No,
probably
it's,
an Ursa Major, right? Isn't that the nose of the bear?
Yeah.
Okay, 7.7 degrees northwest of the galaxy. All the NGCs are galaxies. They're never a.
No, that's not
These
true.
are all sorts of things.
Is it the word G, galaxy?
No, NGC, Ron, is New General Catalog. And that's where Herschel's son and other astronomers through the ages have expanded Herschel's list of objects. So it's all kinds of things.
That's from
It
her.
dates from 1885, I believe.
Oh, probably. Well, that's probably when they started calling it the New General Catalog. But
Yeah, right. That's the last, right.
Huh. Okay.
I was trying to say it's rather old for being labeled new.
Yeah.
Well, I wonder if
Yeah,
there's
coming up in August is the 200th anniversary of Herschel's death, and in England, Pat and I are members of the Herschel Society, and they're having a big retrospective. So they're setting up all kinds of exhibits with his replicas of his telescopes and playing his music. He was a composer, and so all over England, but primarily in the region of Bath.
Well, now, did he discover Uranus?
Yes.
1781.
Okay.
1781.
And there was a story in his talking points about Uranus where it's going to be, and wouldn't believe what I got written. Just look at this. I transcribed Jerry's notes. You want to here it is. It'll spend the next few days through the 23rd. Uranus will 18 arc minutes of a magnitude 7 red giant star. You can find it. That's keeping it in the solar system for now, and out past the moon.
That'll be kind of low in the west.
Mm-hmm.
Okay, well, that's all we had on that. Interesting.
Here's Uranus here. I think this is Cetus the whale, and here is Aries. Is that
Okay.
a goat or a sheep?
It's
or
a ram.
It's a
the
ram.
golden fleece.
So
The golden
a ram
fleece in
here.
the legend.
Yep.
Okay, and
there's-
people say March comes in like a lion and goes out like a lamb, and usually they're talking about the weather. But
Mhm.
also Leo is rising and Aries is setting. So
Right. Out like a ram.
yeah.
What year
Here's a
did you-
Pleiades over here.
80s?
Yeah.
Well, what does this mean, Mr. President? No faint fuzzies this week. This is from your talking points. Cassiopeiae, we're talking about west. The big W, not west. I put W's or S's or, N's to notify direction. And that, in this case, it's a big W or a chair, sort of. Some people think it's a side recliner.
The throne of the queen.
She's the queen, just southeast of stars Navi and Shadar, both magnitude 2.2, right side of the W. So will we be able to see that this week due to the full moon?
Well, that's the idea. You don't have any faint fuzzies because you have the moon up there
Yeah.
in the sky.
Oh, that's what it is. Okay, got it. Well, good luck, gentlemen.
Well, 103 is going to be easy to pick off. I think it's going to be high enough.
Open
103, I
cluster,
call the
yeah.
Christmas tree. The Christmas tree. 34 is real big. big and bright.
I was going to try to share my picture of the moon that I took at Westmont when it was in an eclipse. And unbeknownst to me at the time I took it, Uranus was about 1¼ moon diameters away from the moon. I found it when I processed the picture. But I can't share it because somebody else is on here now.
Anybody know how we learned there are some light rings around Uranus? Was that a flyby? There's no way you're going to see those in a telescope, is there?
It's an occultation, Ron.
Yeah.
Could you put that finder chart back up and zoom out so we can see the legends?
Okay.
Yeah, this is what the sky looks like at 7 p.m. on the 16th, later this week. You can see the glow of the sun down there on the left. So this is well placed in the evening sky.
Mm-hmm.
And the star Eta Cassiopeiae is the one in the circle.
The bullseye.
The bullseye. Okay, thank you.
Oh, Jerry, I want to show this Wikipedia image they have of Eta, and I think it shows it binary companion. It's 2 stars.
Yeah.
Let me see this, and they're showing it going around each other. Kind of a weird pattern. They get close and they get farther away. The 2 stars.
It's foreshortened. Well, it could be. Could be elliptical and foreshortened.
That makes sense.
Yeah, they do speed up a little bit more when they're together.
And they're different colors?
Yeah. One's orange, one's whiter.
Huh. The whiter would be denser, smaller, bigger?
Hotter.
Hotter. Got it.
And you're not going to see that motion over the course of an observation.
Right.
That's over months or years.
Eta, anybody know the source of that? What is that? An ancient Greek
It's a
goddess?
Greek letter.
It's
Like
a Greek,
Omicron.
Yeah.
like alpha.
Interesting. Okay. I don't know if I've ever seen 2 rotating stars. All I've seen are clumps and still, but.
You won't see them moving, Ron. That's over years and years.
Is it really? Is that what it is?
And they're also revolving. They're not rotating, although they probably do rotate.
And they're hundreds of AUs apart, I assume.
Yes.
Parsecs apart sometime.
I don't think they're that far apart. Let's see. It's a 480 years. 480 years for their orbit around each other.
Well, those pictures weren't taken over 480 years.
Yeah, that's a simulation, of course.
Yeah. And Jerry witnessed the first revolution.
It got me into astronomy.
Yeah, that's pretty good.
All right. Well, Chuck was telling me earlier they just discovered another binary where each of the 2 stars has its own little solar system, and then there's a planet going around both of them.
Yes.
Okay. We'll talk about that someday when we learn more. You want to go out with NASA to the Psyche, not Psycho.
One more thing, Ron, on that, the distance apart, there actually says an average distance of 71 AU. So Pluto's like between 30 and 50. So this would be the stars are separated a little bit more than what Pluto is from the sun.
Oh, it's close.
Something I just read, I'd like you to verify. Brown dwarfs, which are not big enough to get fusion and get lit like a star, but they're bigger than Jupiter, are everywhere, but we just can't see them. And I wonder how many of them have their own little pseudo solar systems. Now, they form in the middle of the gas, and the little planets or whatever you want to call it going around them in the cold without stars. Is that true? You suppose there's jillions of brown dwarfs?
I guess it's the same ratio of planets to stars that we see for the regular mainstream stars.
Is that right?
So I would guess that they have a lot of them have planets. Brown dwarfs are like super big planets that are still contracting under their own gravitational collapse, and that gives them the heat. Now Jupiter is an extreme case of that. It's a very, very dim. It emits more radiation than it receives. So it does heat up from its own gravitational collapse or pressure, and it does emit in the infrared.
But there are probably solar systems that aren't solar out there with brown dwarfs in the middle, having
Yeah.
a planet orbit that will never.
I would guess yes.
Wow. As well as a fair amount of black holes everywhere that we don't see.
And as a
think there
scientist, I'm making a swag, which is a scientific wild ass guess.
I keep reading that there are more black holes in the universe than there are stars.
Oh my God. You don't
A
tell
lot
us
of them are small. You can't see them.
And rogue planets are roving around without any home, any system to be part of. My God. All right, shall we go to Psyche? Who in the world named an asteroid? There must have been a Psycho. It's a billion and a half miles away. I guess NASA's ready to launch a solar-powered trip to this mysterious metal-rich rock out in the asteroid belt. It'll be August of this year.
Yeah.
Okay. It's got a big, huge panel, cross-shaped solar arrays.
Yeah, the event here is that they just married the solar panels to the spacecraft and then folded them up to pack it for launch.
Wow. And that's enough energy to power 3 homes, supposedly.
It is at the Earth's distance from the sun,
Yes.
but another 1.5 billion miles out there.
It'll get less.
Yeah, quite a bit less, only 2 kilowatts. But it's a super enhanced, or what is it called? Modified solar array to be more efficient.
Do the solar rays on our satellites ever get degraded due to micrometeorites?
Yes, of course.
That's what I thought. They never talk about that.
Mhm.
But now the big shield behind James Webb had no solar panels on them. That was just a
Yeah, no, there's solar panels.
Are there solar panels on that big wide thing that's filled
Well,
out?
there are solar panels separate from that, but
Okay, well, they'd have to be on the sun side of the shield,
mhm.
obviously. Well, this Psyche, it's in the belt, right? 172 miles at its widest point. They're going to get out there, I guess, in 3.5 years. It'll arrive in 2026. Are we thinking of mining this sucker for metals?
Oh yes, many people are.
Yeah,
But
I
it may
got-
go the way of mining the oceans. It never really pans out. You don't know. It's in the future.
all right, and the Greek word Psyche's got to have something to do with mental case.
Goddess.
Goddess, Psyche.
Chuck probably knows.
No,
What's-
no, I mean, it's
Okay.
goddess of intellect or something. I don't know. Let me do a
Okay.
quick lookie.
That looks like something I removed from my left cheek a year ago.
That must have hurt.
we got the asteroid tumor
Greek goddess of the soul.
or
There we go.
cyst.
Thank you, Chuck.
Uh-huh.
Psycho puts them over the brink. Psyche is our regular brain power, I guess. Fascinating stuff. JPL build everything or is building stuff.
Mhm.
Cross-shaped solar arrays, 5 panels, 800 something. I can't read my own writing. 800.
Oh, it opens up this way too.
There is in the asteroid belt, there's a tremendous amount of raw materials of every kind, water, volatiles, even metals, and they can be mined without having to dig into the earth under heavy gravity and create an entire economy out in space that is not dependent on the earth. And I think the vehicles that are being developed by Elon Musk are a step in that direction.
Mm.
His things will have tremendous volume of passengers and cargo, and they can be refueled in space. They don't need to come back to the Earth. They can land on Mars, for example, which has a lower gravity, and it doesn't need that great big giant booster like it does to get off of the Earth. So there can be a whole economy out in space that does not depend on Earth. And I think that's in the future if we don't blow ourselves up first.
Or cook ourselves.
Yeah.
Of course, we've been reading this in sci-fi for years.
Yes.
Twilight Zone had a few episodes like that.
Mhm.
Fascinating stuff. But There's another interesting nebula out there, if you want to go there, NGC 3576. A bright emission nebula in Sagittarius Arm. You want to talk about that?
That'll be early morning.
That's very early morning. Yeah.
Not a repeat of what we were just talking about, is it? Statue
That
of Liberty.
the astro picture it says 26 CDK, which is corrected Dal Kirkham. Is that your telescope, Jerry?
No,
Okay.
Okay, what are we looking at? What is this, gentlemen?
That's the NGC.
Oh,
That's the picture.
Looks like an emission nebula.
Yeah.
emission nebula. Now, what does that mean? It's not a planetary nebula.
Well, a planetary nebula is an emission nebula, but this is a
Right.
non-planetary emission nebula.
Thank you, Chuck.
Well, the Eta we had earlier, this is Eta Cassiopeiae. No, I can't even read my own. writing.
Carina.
Eta Carini? No, this
No,
is not
No?
that.
yeah. Eta Cassiopeiae you can't see here. You can't see.
Oh,
here.
it's-
two
it-
figures.
Oh,
down.
it's a few thousand light years from Eta Cassiopeiae. I'm sorry. Another nebula about 100 light years across, 9,000 light years from Earth. Its nickname is the Statue of Liberty. Anybody know why that is?
Can't you see it in the
Looks like
image? Take a look,
What?
Ron. You can. There's the Statue of Liberty.
There's the torch right there. Thanks, Tom.
Okay. Need
now
drugs.
below her feet, I just put this up there, even though we can't see it because it's a real cool picture. But some people see the head of a bull looking down under her feet.
Okay, yeah.
Okay.
Right in there. It's
Oh
higher
yeah,
up,
yeah,
Tom.
yes.
A little higher up, Tom. No, more to the right. Just below, right there. Yeah,
Oh,
right in there. You'd see
That's
that's nostril and mouth, and then there's a star for the eye,
And the horns
Yeah.
right above it.
looking
That's actually-
downward.
Actually pretty neat. Yeah.
Oh, I get it. Yeah, yeah.
Got quite a snout, huh?
Yeah.
Another one of your John Herschel discoveries, March 16th, 1834.
Wow.
Yeah, that was William Herschel's son.
The sun, yeah, that's.
Oh, okay. Well, you're quite
He
an
may have seen that too, Chuck, from the African side, huh? South African side.
Yeah.
man, you've
So-
done those graphics.
So, Chuck, the constellation Carina is at the bottom of the boat. Just
Yeah, the keel.
Yeah, that's the keel
keel.
of the Argo Navis.
For those
Ba-
of you who have a good southern view, you can still see Canopus in the evening. There's Canopus, the second brightest star in the night sky. We see it here easily at 8 now, 8 in the evening.
It just peeks over the islands.
Yeah,
so if we're at latitude 34 degrees, we
mhm.
can see down how far below.
About minus 56, Tom, roughly minus 56.
Okay.
And you have to have a perfect southern
You
horizon,
have to have a
Yeah.
0 degree. That's right, Jerry, 0 degree.
like over the ocean.
Yeah,
Yeah.
we
Yeah,
pretty
and
much
that- and
have
that's-
that for, some of these interrupting hills.
And that's
It's 35
90
is that-
degrees. That's 90 degrees minus 34 and a half to get how far
Right.
south we can
Right.
see.
Yeah.
Yeah, that's how I came. Thank you, Chuck.
Is that nebula showing on this finder chart?
Right here in the
Oh,
red.
red. Okay,
Okay.
it's not labeled. Yeah, good.
Interesting thing about these reverse negative shots where the sky is white and the stars are round dots of black. The black holes
Yeah.
should be white holes, shouldn't they?
Those for some people, those are easier to read under a red flashlight outside in the dark.
Is that
So,
right?
Ron,
Yeah.
Ron, I was just going to point out that there used to be a larger collection of these separate little constellations called Argo Navis, the ship Argo.
Yeah.
So now what we have is they broke it up in about 1930 into Vela, the sails, Pupus, I call it the poop deck, but people call it the stern, and then Carina's the keel. Okay, so those comprise the old Argo Navis. Okay,
And
The
there's
ship-
also like-
the Argonaut ship.
There's also like Pyxis, the compass, and
Yeah, that's right. Yeah.
Volans there is a flying fish that's jumping up next to it.
Yeah, Volan's a flying fish. Musca, of course, is a fly. Dorado is what is that, Chuck? That's a
Like
dolphin.
that's the dolphin fish. Yeah.
That's yeah. But
How
you know,
much-
we can't see these things. We can't see these things here because we're too far to the north. Okay.
Really?
Chuck and Jerry have seen these because they've been down the southern part of the Earth.
Oh, so you're talking about Australia and south of the.
Yeah.
Oh, yeah. Easy to see there, Ron. You can think of all these things going up as you go down on the Earth. Okay.
But in Australia, they don't get the majority of those 88 that we see, do they?
There's a lot more smaller ones, I think, down there.
Yeah.
They can see Orion.
Yeah,
Right.
Neoplacidus, by the way, is a navigational star. A friend of mine who sails a lot, gave me a chart of the navigational stars. I remember that was one of them, Neoplacidus, which we can't see. We can't see that.
A lot of them were done, in the 1600s and farther on as Europeans travel south,
Mhm.
into the southern seas. And of course, the local inhabitants had all kinds of their own constellations, but these are the ones that ended up official. And
Yes.
for instance, talking about John Herschel, Mensa down here is the
Mhm.
table, and that's representing Table Mountain at the very southern tip of Africa, which is where John Herschel went and observed the southern hemisphere.
That's neat. That's neat, Chuck.
Well, has there been any detectable movement in our lifetimes, gentlemen, of any star? Or are they all pretty much?
Sure. No.
Oh, yes.
I mean, where they actually traded places, moved.
Yes.
Yes.
There's some red dwarfs that you can see in a backyard telescope that you can see motion in a couple of months. If you take a picture or if you make a drawing, you can see the motion.
And Ron, the other point here too, a little different from what Chuck was mentioning, is that because of the wobble of the Earth, stars, physically change their positions from our perspective. And very precise telescopes like, the one at Westmont knows this. And so you have to call up fresh charts if you want to find things.
But the Earth wobbling wouldn't make it move from its position in the sky. Just the whole sky moves a little.
Yeah, when a star moves across the sky, it's called proper motion.
That's right. Mhm.
And the most famous one when I was a kid was Barnard Star.
Yeah.
Mhm. Mhm.
That's the easiest one.
Yeah.
And there's another one, Piazzi's Flying Star. It moves really, really,
Yeah.
really. Yeah.
Yeah.
Barnard Star was in the news recently, wasn't it? What was that about? That's not the lady that found a whole bunch of planets.
No.
That's
No. I think it's named after that astronomer up at Lick, right, Chuck?
Yeah. E.
Barnard.
Barnard, he was specializing in dark nebulae, or at least he's known for that.
Yeah. Mhm.
And there's Barnard's Galaxy. That's probably what you heard of. That's a little sparse galaxy that they were probably looking at to study distribution of dark matter.
Mhm.
Huh. What are we looking at now?
This is something, this is Comet Catalina, which in normal vision is dark, oops, it went away. And if you put it in inverse video, you can more easily see the two trails, the
Mhm.
dust trail and the ion trail.
A comet. We haven't talked about a comet.
Yeah.
Well, you're talking about inverse video because of that
Yeah.
graphic that you had.
Oh, did you?
And
throw
that
up?
also works well sometimes
All right.
when looking at comets or when displaying an image of comets.
Yeah. For seeing faint detail.
Yeah.
Yeah, it brings up the faint detail, right?
All right. Fascinating.
And when you look at an astronomical journal, frequently the pictures are in negative form. So the background sky is white because in the printed medium, it shows up much better for faint objects.
Wow.
Tom put up that image that had the that nebula in red as a little red circle, and some of the big Tyrian star atlases and things up until about the year 2000 or 2005, they would mark galaxies as little red objects, little red ellipses or circles or things like that. And the whole reason you have these star charts is to go out at night and look at them to find things, or one of the reasons. And a lot of people, of course, you're using a red flashlight, and these galaxy images with the symbols would just totally disappear under the red light.
Yeah.
So people complained about that, and now they tend to mix different colors in.
Yeah.
Just loses its impact with somebody like me.
So Chuck, just one quickie, if you would mind displaying your T-shirt there.
Yeah.
Yeah, I ate some pie. I just figured
It's some
it out.
pie.
And it was delicious.
I can only see the top of it. It says, I ate some pie. Pretty
Okay.
cute.
Mr. President, would you like to get rid of one more, let's see, spherical shaped, this should be a planetary nebula. You just mentioned it briefly, Abel 7, is that where it's
Abel
going?
7, yeah, it's in there just because it's a pretty planetary nebula.
Okay. Inside Lepus.
Yeah,
What is constellation Lepus? Is that it?
yeah.
The hare, rabbit,
18.
Yeah, that's the rabbit under the feet of Orion.
Yeah,
right.
so it's
Oh.
visible from the north. So this is, it's just very well processed, nice image. It
Yeah.
was taken with a reflector because you can see the diffraction spikes on the stars.
Mhm.
The color in the stars is varied. The person that processed it kept everything saturated so that it did nothing washed out with an R in it. So
Huh.
it's just a very nice image, caught my eye, so I put it in.
Abel 7, not an NGC, not a Messier.
No, it's another catalog, just like
Mhm.
NGC is.
Okay. What is Lepus? What is it?
The hare,
The hare,
rabbit, little rabbit.
rabbit.
Oh, the
like
rabbit.
that's right underneath
You
the
can look
line.
on it as what Orion the Hunter is chasing.
Okay, right.
That's a little bit of an overkill. He's, got this great big club coming down on something.
Okay, and that ball we're looking at is 8 light years in diameter. The whole thing's 1,800 light years away.
There is a star at the center that you can see. That is the star, the sun-like star that burped off its outer shells.
Wow.
And now it's a white dwarf.
Yeah.
That's 10
There's
billion.
a quote from Fritz Zwicky about spherical.
Yeah.
Astronomers are spherical bastards. No matter how you look at them, they're just bastards.
He said that about a colleague of his.
Yeah, he was a
Well,
real.
okay, they must have cleaned this up from when I Googled it. That's what came up.
Yeah.
He was quite a charmer.
Yeah.
Oh yeah, he was irascible.
Every now and then you get famous scientists that are that way. I guess Newton was like that too, and I read.
Too much mercury.
Yeah.
Well, we got a couple of questions to answer later on. Before we go to the dark matter in the Milky Way and its shape as opposed to us, because that was a question posed by you, and we're going to give you an answer later. We got about 20 minutes. I'd like to check out the moon count in Saturn. I guess it holds the record now among the planets for the most moons, and none of these were discovered by Cassini. It's
Way too faint for him. Go ahead.
Some of them were discovered in images from the Cassini spacecraft.
Well,
Yeah.
they were. Well, it didn't say that in your notes. It said
That's
there's
what I thought he meant. Yeah.
observatory in Hawaii. That,
Yeah, a lot of these really dim ones may have been done by observatories, but there were some found by Cassini, by the Cassini spacecraft.
Now this is old news from 2019. 3 years old. How fast we move. The reason I put it in here is because this graphic shows prograde and retrograde motions of the moon. And that question has been asked several times by the Baron about do the moons go around the same way the planet rotates or opposite? And this shows which ones go which way.
Mhm.
See the green?
And there's the probable reason there's such a swarm of little moons there in the retrograde group is that they may have impacted with that prograde moon.
So the red ones are retrograde, as you can see. The blue one and the green one are prograde, which means it's going the same way as the planet rotates. Retrograde means it's going the reverse way that the planet rotates. So which way does our moon go around us, retrograde or prograde, Baron?
I'm going to say prograde.
Mhm.
I don't think I've ever heard retrograde. It's not, we couldn't handle it going the wrong
Well,
way.
we've only got one moon, so we don't do pro and retro for it. So
That was tricky. That was tricky, Jerry.
I know it's tidally locked, whatever that means. Well, of course I know what
it's
that means.
tidally locked too.
Yeah.
Yeah.
But is this diagram we're looking at to scale? Is that pretty much how it?
I believe so. Yeah, the picture, I don't have the citation, it's in the text, but the picture was taken by a person, and that's projected. The other things here are computer drawn orbits.
Well,
Anyway, you can see where the different names come from. And I'm going to let Chuck do that talking because I'm getting a lot of background noise from the tree trimmers, so I'm going to mute.
All right, Chuck, answer this. Why don't they collide?
They do occasionally.
Really?
Yeah, that's why you probably have such a swarm of the red ones. There's probably a collision in the past that broke up a larger body. It's in here.
The other thing is they don't quite collide. They go into a little tight spiral orbit, and one of them gets kicked out.
Well, that's if their relative speeds are very slow relative to each other. But in this case, they're prograde and retrograde. So you'd get a
Oh yeah,
big wham.
yeah. Okay.
Yeah. So the one group is named after Inuit mythology, and there's another group based on Norse mythology. And then the blue ones, you get all this French mythology, or what are they? I guess
Gallic group. It's
Gallic.
Inuit group, Cephei group, Norse group.
So those are based on their orbital characteristics.
Were we just looking at the 20 new ones? There are 60 something others that are closer into the planet that aren't depicted on.
Oh, no, some are closer, some are farther away. This is just this particular grouping.
But some of them are the shepherd moons, right?
Yeah, those are little tiny ones down by the rings.
Yeah, in the rings.
Yeah.
Rings aren't considered a moon, are they?
No. Unless you want to have billions and billions of moons.
Do we got a name for all of them?
Not yet. Tom has just put up, the list. And you can see some of them have names, but they're still deciding on the names on all the ones that are S/ in a year. So that's Saturn is the S, the first S, and then / the year it was discovered. And then S2, S3, S whatever is the order in which they were discovered in that year.
Is 2004 the year that Cassini got there?
Sounds about right.
But most of the new moons are like 3 miles across, I understand.
Or less than that, maybe 3 kilometers.
Well, okay, that's about 2 miles. But would they be captured asteroids?
Yeah, captured Kuiper belt objects, captured asteroids, captured small bodies. And there was one of them, Tom was just down there kind of highlighting poorly observed. There were a couple of them that were lost. They had an initial detection from them, maybe from Cassini, maybe from some telescope, but then they couldn't, for some reason, like Saturn was behind the sun from our point of view, they couldn't do follow-up observations, and they lost them. They couldn't find them again. And there were a couple of amateurs that were digging through these images on the web that managed to find a couple of them again.
Huh.
So, just sitting in your home doing data mining, you can contribute to scientific knowledge.
But the big important ones, like the one highlighted on this list in yellow, orange, Titan, that's the one we're going to visit, I guess. Isn't there a probe being planned?
We've visited it already. Cassini dropped the Huygens probe onto it.
That's true.
And we're talking about visiting it with, I know there was a plan for a balloon. I don't know if they're going to do that. It's got a thick atmosphere, so it would be good for balloons. But they're talking about various flying objects that you could send there. Drones basically that would be able to move around in its atmosphere. And I think now they're leaning toward a helicopter type object.
Another ingenuity.
Yeah.
Well, that's a double whammy, isn't it? Because their atmosphere isn't very transparent. So if you have a solar powered helicopter, you have, you don't want it. It doesn't charge well while it's flying. You want to be on the ground where it's not using power.
Well, I got to tell you that that video that we got from Huygens as it landed on Titan really showed the shadow of its parachute, didn't it? Go by.
Yeah.
So there must be some sunlight getting to that surface.
There's some. It's not really intense. I mean, not only are you far from the sun, but you got that thick atmosphere, and it's kind of like a smoggy atmosphere. It's a lot of methane and nitrogen.
If there is life there, it's on a totally different basis than what we got, I would imagine.
Yeah. The temperature is like minus 300 degrees Fahrenheit.
Methane lakes. Can't imagine.
Yeah, it's got a whole hydrological system, but it's based on methane instead of water.
Uh-huh.
Methane rain.
Methane is just one of many what are they, organic?
Yeah, organic molecules.
A hydrocarbon. Yeah.
Yeah.
Is it a simple compound? How many atoms make up a molecule of methane?
CH4 methane.
Hydrogen is a molecule.
Huh.
Oh, I'm sorry. Water. That's got two. That's a molecule.
But in the
If you want to count the two oxygens.
do they make the stuff in oil refineries along with butane and propane and?
Well, that's naturally formed. I mean,
it's under the lakes and in the ground. Okay.
Yeah.
What is natural gas really? What is it called? It's not methane.
Methane.
Is it?
CH4.
I mean, there
Okay.
are probably other components in there, like butane or some of those other. I'm not a chemist. I don't know all the names of some of these tanes that are in there, but there are some other carbon and hydrogen combinations that are probably in our natural gas. But the major component is methane, and it doesn't smell like a lot of people think. You say methane and they go, oh yes, but they actually have to add an odorant to natural gas so that you can detect when there are leaks.
Yeah, I was going to say it's butyl mercaptan.
Yeah.
But the only way
skunk
methane,
stuff.
what?
Skunk stuff.
The only way methane can be liquid is if it's that cold. If it were here, and it is here, it's a gas.
Yes. But they refrigerate it and ship it as liquid natural gas because it takes up a lot less volume.
Yeah, right. Sure.
You see here, Ron, it says that Titan's atmosphere is 97% nitrogen and less than 3% methane.
Oh, interesting.
It's got a lot of smog, though.
Yeah.
Wonder how cold it has to get for methane to become solid like ice.
Well, minus 300 will do it because there is solid methane there.
That would be a cold bath to take in a methane lake on Titan. Well, interesting. Gentlemen, we got one big question to answer, but I thought I'd check with any of you that might know an update. If there is one, anything changed with the James Webb now that it's in place and everything's unfolded and they're putting in the 18 hexagon. Has it been fired up and ready to go?
Not yet.
Not yet.
They're still doing the fine calibration on the mirrors, the phasing.
Okay. So since Bruce Murdoch and I are about the only two among us that go on YouTube and watch some of those stupid videos, all those videos on YouTube that say, look what James Webb saw, this incredible constellation that didn't exist before. All of that is BS, isn't it?
Yeah, exactly.
So Ron, I've got some.
I thought maybe they were using one of their guidance cameras, small camera that picked that up. In fact, Chuck mentioned that the last time we mentioned what you and I just said.
So Ron, I've got some food for thought for the group. Okay. So usually at the end of an astronomy magazine every month, they have this little section called Ask Astro. And every now and then you get a very simple question that has a very, basically an intriguing answer. So somebody asked, when you look at the COBE map, the Cosmic Background Explorer, how far away is that information? How far away is it? Okay. And I think Jerry, he's muted right now. Anyway, so the fellow who answered the question is an astrophysicist in some Eastern university. And he said, basically, what you're looking at happened roughly 300,000 years after the Big Bang, when basically light could finally get through, okay, after the Big Bang. And he says, at that time, the information that's coming out, the photons basically are in the infrared, okay?
Now they are.
Yeah, just
now
correct.
because they got stretched.
The answer is really, really neat. So he goes, we believe that the universe is about 14 billion years old, right? And so he says in the expansion of the universe, okay, basically that infrared light has gone all the way to about 1 centimeter information through COBE. So it has been extended and extended by its travel through space-time. So that now when you're actually looking at the COBE information, you're looking back 40 billion light years away, 40 billion. Really neat answer. And it's, I just wanted you guys to munch on that if you wanted to.
Tom, did you say COBE, COBE? What is it?
Yes.
Yes, COBE, the Cosmic Background Explorer.
Oh, yeah.
That's a satellite that took the image.
Right. That thing went up in, I don't know what, Chuck, about 1990, 91, something like
And there've been some follow-ons there.
Yes, yes. There've been the Planck. The Planck is
Yeah.
the one I can think of right now.
Also,
if-
talking about questions, I saw Tim Crawford was saying there's a red star in Lepus. That's our Leporus, Tim.
Yeah, that's a neat
Ah.
one.
Very
That's a
red carbon star.
It's a beautiful carbon star. Yeah.
Carbon, mostly carbon, huh? But we have reached the limit because of the red shift stretch, where we can see across the universe 13 billion light years, but with our regular telescopes. That's why we're going.
That's look back time, Ron. That's the
Right.
time that they left there.
Right.
Yeah, I understand.
but
that.
since
Where they are
then-
now is about 46 billion light years
Yeah.
out.
Since
The
then, the
furthest
expansion,
objects.
has pulled them out.
That's
But
right.
the light waves have stretched into the red on the visual scale. If it keeps stretching, it'll go into radio waves, won't it? Why
Yes,
can't we
yeah,
watch?
Well, it
the
actually
cosmic microwave background, Ron.
Right?
It is microwave. It's about a centimeter. The peak on the curve is about a centimeter.
We're not at the edge of the universe. It'll probably keep going, won't it? We'll just see
Well,
Right.
radio.
Well, there's always an edge to what you can see.
Right.
Yeah.
And he also makes
That's
the
how
point.
come we don't know how big is the universe, because the furthest out we can see is, 13.8 billion light years.
And
Actually,
if
you
you
can only
add,
see 13.5, right? Because of the atmosphere. The universe didn't become transparent until then.
Right.
and
About three-
teenagers are actually right. You are the center of your own universe, because depending on your position relative to somebody else, you can see farther in the direction on your side by the amount you're away from that other person. So everybody's the center of their own little sphere that's at
Right.
least now around 13.5 or 6 billion light years in radius.
Right.
And because, and Chuck, too, don't forget, because the universe is basically isotropic, it means that people kind of see the same thing at about the same distance, right?
Yeah.
Okay. And it's also homogeneous. So somebody in another galaxy would see some pattern pretty much like what we see Kobe as. Okay.
But
So-
the James Webb is a radio telescope, is it not?
No, it's
No,
Infrared.
Infrared only,
infrared.
only part of the color spectrum that we can't see. Just between colors and radio waves is infrared. Interesting fact. Shall we answer the question in the next 5 minutes, gentlemen, that our esteemed president posed? Is the dark matter shape of the Milky Way, get ready, this is probably not one of your favorite subjects, Jerry, the same as the luminous matter shape, even though we can't see dark matter? I guess we know what it's out there. Difficult. One way to tell? What is one way to tell?
So you have these streams of stars going around our Milky Way,
Aha.
and you can calculate the gravitational pull on these stars by watching their detailed motion. And when
Whoa.
you do that, you come up with the answer that no, the visible matter and the dark matter don't have the same shape. The
dark matter is going to be spherical, I would think.
roughly football shaped,
Okay.
close to spherical, but the inner core of the galaxy, so I should have highlighted it so I could pick it out real easy, is tilted one way, and the outer core is tipped, or the outer regions, it's tipped.
Another way.
It's pretty, other way.
I see.
Various ways.
Can we see those rings?
Those rings, this is an artist's perception, but we can see the stars in those rings, resulting from past galactic collisions.
Wow.
And tidal effects.
Yeah.
Mhm.
Okay, so we've cannibalized them from some of our recent close neighbors.
Yeah,
Right.
some of these it says are 70,000 light years away. They've been shredded and stretched into thin streams around our Milky Way. And these are from a Sagittarius dwarf galaxy.
Wait a minute. What did you just say? This is a Sagittarius dwarf galaxy? What does that mean?
Like
Yeah.
a Sagittarius.
Oh, like
Yeah.
it. Okay, but that's the Milky Way in the bottom middle.
Yes, you see our barred spiral down there.
Yeah, and
And probably one of those innermost rings is representing the Sagittarius dwarf galaxy.
Mhm.
oh,
Because
Wow.
from our point of view, it's in the direction of the center of the galaxy.
Right. So in the center, if the dark matter halo appears to be a flattened sphere, with the long axis pointing in the direction of the disk. But as we move outward, the halo flips. So the football is balanced on one of its points as the galaxy swirls around it. So they're less stream-like. We can't resolve anything like arms in them, but appears to be lumps. So no, the dark matter and the luminous matter have rather different shapes.
Wow. There are some galaxies out there they determined don't have any dark matter in them. Have you heard that?
I have read that there's a galaxy that's almost completely devoid of dark matter. Apparently, it's mostly all luminous matter.
Then why wouldn't it fly apart?
Well,
Well,
it's still got gravity, Ron.
What?
It still has mass, so it has gravity, so it wouldn't fly apart, just like our solar system doesn't fly apart.
Yeah, but we're in the minority. What are we, 10%, 7, 8, 12%, and the rest of it's dark matter? Have you heard that?
5%.
5%.
5%.
Except in that galaxy where it's mostly 90% luminous matter.
Yeah,
Well, that
a
answer,
local concentration.
so the answer is no. They have different shapes, so it's a
Right.
big blob. We can't see. I'm glad we got that answered. Fantastic, gentlemen. Thank you. You did good. Next Friday, we're going to gather, I guess, out at the incredible Westmont scope. Are we not?
7 p.m. at the Keck Observatory at Westmont. It's next to their athletic fields. It's the first entrance off Cold Spring Road.
Okay, and then on
And
the
masks are required. We had one person show up at the observation at the
That's
museum, even though everything said mask required, who was insisting on not wearing a mask. So
Uh-oh.
Insist that they leave then.
still some
They
scary people out there.
Thank you, Chuck. They will be required at Westmont, masks.
But you had 500 people Saturday night at our star party. Man, I
If-
guess people missed it. I can't imagine that many people in there.
It was
Okay,
If we
very
do
crowded.
attend, is it I was going to ask, somebody wants to look through the scope, have you been vaccinated? And if they either won't answer the question or say no, I just say, please step away.
Yeah, that's your personal prerogative for your scope if you want.
Yeah.
There's nothing wrong about that then.
Oh, there's
Wouldn't you?
nothing. We'll
Well,
back you up.
Well, when you get to be, I'm 80 and I don't want to get COVID because the results are a lot worse than if you're 20.
Mhm.
And either I don't go, or if I have to watch what the infection rate is doing. If it's going down,
Yeah.
I might go, but I don't want to get exposed. And the simple way is if you're 280 times more likely to die if you're not vaccinated than if you are. And furthermore, you're infectious for several days before you have any symptoms whatsoever.
I read
So if you
that.
get people out there that
yeah,
are selfish and they don't wear a mask to protect others, I don't want them around me.
did we give that guy that wouldn't wear one a mask? Or
There
did
was
he?
a lady and she refused to put one on.
Oh, I've seen her in supermarkets. They call her Karen.
Ron, I think they gave her a boot.
Well, I hope you all got N95s. They work better than those pieces of white cloth they give you.
Oh, yeah, those are the best. Thanks, Ron. Those are the best, the N95s.
You got it.
Next, the KN95s is not as protective, but they're pretty good.
I have many and I enjoy wearing them. And Tom, I
Good.
want to bring cookies Saturday night or Friday night, okay? And I guess we'll have an online meeting on the night of the 1st, and Mirek Brandt will be our speaker, talking about LCO, the Las Cumbres observatories, and maybe something about exoplanets if he's listening. Krissie Cook had to be listening today, right? Or was she bailing to go to her new
No,
job?
she commented, so she heard part of it at least.
Bless her heart. Good to meet her. And we had a grand time outside before the star party Saturday. We'll see you again for sure, I guess, next Monday, Tom. We back on duty here?
Yes, at this
11
point,
a.m.,
yes.
The podcast from hell. It's on YouTube. You can watch it. We'll see you on the night of the 1st. Thanks, everybody. Take care.
Bye-bye.